Okay, we are back for the last part of today's lab. This is a continuation of the population ecology lab, right? So it's that same lab in your lab manual, but this time we are looking specifically at some other factors that affect population size, okay? So in that last one, it was the food resources, intra-specific. This is going to be interspecific, kind of, but we're looking at how interspecific factors affect one population, okay? So you're going to have two different populations that you're looking at. You're going to have a dense population, which has 50 individuals, and you're going to have a sparse population that has 20 individuals, okay? And for this, what you're going to be doing, and in lab, you would have little paper cutouts like when, from a hole punch, okay? And they're each going to be on a checkerboard, and you would just have 50 little pieces of paper that you counted, and you would just kind of let them go over the board, okay? So you're just going to have, pieces of paper, 50 of them. And for the sparse population, you just have 20, okay? And what you start off doing is for each population, you're going to count how many individuals in here are more than 30 millimeters from another individual, or 3 centimeters, right? How many are more than 3 centimeters? And how many are less than 3 centimeters, right? Are they next to someone else or not? The ones that are all squished together are clumped, right? Oops, clump. And the ones that are further apart are isolated. And I'm trying to think of let me look at how the lab words it. And they don't really word it. Okay, so we've got clumped individuals and we have isolated individuals, okay? And you're going to have put them through a few different scenarios. So for each one, in the lab, you would just put let your little dots fall onto the checkerboards and leave them there for every single scenario that we're going to go through. Okay, so once you've figured out how many are dense and sparse from one another, you'll use those numbers for every single scenario that we're going to go through. Okay, so what I'm going to do is show you for a moment you're going to be here looking at this population ecology. It's called population ecology data images. Okay, that's the file that you're looking at here. And I'm just going to share this with you. So you're looking at density dependent factors and density independent factors. Now remember, when we talked about density dependent factors, these tend to be biotic, okay? So this is going to be like disease, competition with other individuals, predation, right? And then our density independent factors tend to be abiotic. So this is going to be like drought, or wind, right? Things that are going to should presumably affect a dense population the exact same as a non-dense. It's not dependent on how dense that population is, okay? So what you are going to do is there's a bunch of different images here, which there are it has, let's see, 6 different populations, 7, 8 populations that it worked through. You only need to do it for one. So, some of you can choose population 1. You have your dense population with 50 individuals, and you have your sparse population with 20 individuals. And if you counted, there'd be 20 little dots here. So some of you can choose population 1, some of you can choose population 2, which again, it's just a different picture of a checkerboard with 20 individuals, and then you've got your dense population with 50 individuals. Okay, what has been given to you, so pick a number 1 through 8, roll the dice. Pick one that you want to work off of, and you can just do that for your lab. Okay, so the lab that you're filling out, well, I'll show you what you're doing here, and then I'll go back to the lab and we'll answer questions. Okay, so you're going to want two things open. You're going to need your lab manual, either paper or online, and you're going to need these images. Okay, so you can fill out things in the lab. So for each of them, what has been given to you? So here's the sparse population, and you're told the number that are greater than 30 millimeters or 3 centimeters from each other is 11. So like if I'm circling like this one, they're not close to anybody, right? This one's not close to anybody. This one's not close to anybody. These two, though, that I'm putting a square around, they're close to each other. These guys are all really close to each other, right? So it told you the number of that are greater than 30 millimeters are 11. This population had 20 individuals total, right? So the ones that are close to each other, less than 30 millimeters, must be 9. 9 plus 11 is 20. Okay. If you go into the dense population here, there's so many more individuals, right? So there are fewer that are more spread out, right? So this one, oh, come on. This individual is kind of spread out. This individual, but look, like all of these are within 3 centimeters of someone, right? They're all clumped together. This guy's probably alone. So here, the ones that are greater than 30 millimeters, so like isolated from everybody else, are 10. The number that are less than 30 must be 40 because we have 50 individuals total. Okay, so they've given you how many are clumped together, and you can figure out how many are far apart. So let's just remember, I will now go back and I'll show you how you're working on the lab manual. So for this, just look at these, pick a number 1 through 8 and write down your clumped and your sparse that they gave you, right? How many are clumped together and how many are isolated. So oops, I've got to get here we've got our PDF of this lab. Okay, so you're on this page now, right, of the lab. And you were told, and you're keeping these numbers. Once you've got your numbers, you're set to fill out all the rest of these things. Okay, so for our dense population, we had 10 that were spread out, so we knew we had 40. Sorry, I need obviously a thinner tip here. It kind of looks messy. Let's clear that. Okay, so we had 40 that were clumped together and 10 that were spread out. And for this, we had 11 that were spread out and therefore only 9 that were clumped together. Okay, and if we look through here, it asks for your results. You're going to have to go back a page. It tells you, or back a few pages, right? So these are all of the different scenarios that you're working through. So we start with scenario A, parasitism and disease, and it says you have 2 different populations, right? You have your dense population and your sparse. Determine the distance, which we did. Assume a parasite. I'm at spot number 5 here, okay? This is our first scenario. Assume a parasite has infested each population. Assume that the parasites can only be dispersed from one to another when they're close together, okay? Any individual who's within 30 millimeters of another will contract the disease and die, all right? So calculate the percentage that die from this. Okay, so we go back here. Okay, so the total number infected, anybody who's less than 30 from another, right? They're not spread out, is going to get this disease. So 40 of these individuals got it in this population and 9 of the individuals got it in this population. Okay, now what's the percentage? Well, the percent is just the number that got it out of the total. So 40 out of 50, that's 80%. 9 out of 20, that's 45%. Okay, so we can see percentage-wise, a much higher percentage from the dense population that had 50 individuals die, just because they have the exact same amount of space, right? Everybody gets the same checkerboard. And if you've got 50 individuals, everybody's kind of squished together. If you only have 20, everybody gets a little more space to spread out, less disease. Okay, so which had a population had a greater percentage, right? So I'm doing it for population 1, so maybe you should choose a different population to work through. Okay, the next scenario that you're working through is predation. Okay, so you've got these dense populations and these sparse populations. And which one's going to attract more predators. They give you a formula, okay? And this is made up. This is not really how predation works, but this is an example, it's kind of a model for it, okay? So what they're saying is that any individuals that are less than 30, 75% of them die. So if you're clumped together with a bunch of others, you have a 75% chance of dying. But if you're all off on your own, it doesn't mean you're totally free, right? A predator could still come and get you. If you're off on your own and you're more than 30 millimeters from someone else, you have a 10% chance of dying. Okay, and then it says just to round up. So if we look here and we go back to these pages, what you're going to do is you're going to write your number that are clumped together times 0.75 plus the number that are isolated times 10.1. Okay, so for population 1, if we do times 10.1. Okay, so for population 1, if we do this, how many were clumped? We had 40 clumped times 0.75. And this is our dense population, right? So this is for our dense one. You have to do this for your sparse one too. And then you had 10 that were not clumped times 0.1. Okay, so how many die from predation here? It's 40 times 0.75, which is 40 times, it's 30. Okay. Oh, I should have been able to do that in my head. So you have 30 plus 10 times 0.1 is just 1. So 31 individuals are killed by predators here. Okay. So your percentage is 31 out of 50, which is 62%. Okay. And you'll do this again for the sparse population, right? For them, the number clumped was 9, right? And the number isolated was 11. So you would just plug those numbers in. All right. Now, here's where, so those that you're going to fill that in for this, and then we go into other weather conditions. So now we're looking at abiotic factors. These are density independent. We're not expecting these to impact a dense population any differently than a sparse population, right? So these are going to be a little more random as to whether you're close to someone or not. If we look at these two weather conditions that we're looking at flooding, and it says any disc that is more than halfway on a red square dies, right? If you get wet, you die. It doesn't matter whether there are 100 of you in the room or one of you in the room. When the basement floods, y'all get wet, right? And then a windstorm, for this one, it says the lines are windy and sunny and kill that organism. So for this, you're going to go back to those. You're not looking at whether they're close to each other or not. What you're going to be looking at is here, right? First, let me clear these drawings. First, we're looking at anyone who's on a red dies, okay? So more than on the red or more than half on the red. So I'd say that one, that one, that one, right? That one, both of these, that one, that one, that one, that one. So what do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 are on red. They all die. This was 10 out of 20, so 50% die. And then you'd compare it to your dense population, how many are on red, right? And then the next one you're going to do is how many are on a line, right? So here we've got 1 on a line, 2 on a line. I'm not going to count that one. 3 on a line, maybe 4 on a line, right? So you just kind of go through 5, on a line, 6, 7, 8, 9, 10. So here we've got 10 on a line in our dense population. So that's 10 out of 50 or 20% die from wind. And you would compare that to how many died from wind in your sparse population, right? For population 1, this is our dense, population 1 sparse. We haven't done our line counts yet. And here, what you would expect to see, but it'll be interesting, go through, are the dense populations. When we were doing both predation and disease, the dense population is affected more than the sparse population because they were affected by proximity, right? Being put together and smushed, there's more competition for food, you're attracting more predators, you're spreading more disease, right? But when we're talking about weather events like rain or wind, it doesn't matter whether there are a lot of you and it's squished together or not. So those shouldn't have as big of an impact, those density independent factors. So go through each of these 4 scenarios, right? I'll go back to this exercise for you. As we're going through these 4 scenarios, you have your parasitism and disease was the first one, right? Your predation, where you had the formula for the second one, and then those weather conditions, okay? And then there are just a few questions to ask. Which population had a greater percentage killed by disease? So therefore, is parasitism density dependent or independent? And then we did our predation calculations. Is this density dependent or independent? And then you look at your weather one. Is this density independent or dependent? Okay. And the same with wind. All right. So that is the end of all of these labs. And any questions you have, send me emails, or we can, we will go through all of this again when we do our review before lab exam 4. Okay. Bye, guys.